In today's video, I'm taking prototype parts designed in Onshape and turning them to final metal casting in less than 24 hours. But wait, there is more. For this, I'm going to use my brand new CNC and lost form casting method. Here you can see the final part. Now, let's go ahead, quickly unbox and assemble my brand new 3018 CNC. It took me some time to get this machine assembled, but I'm very happy with the result. Let's quickly zip through this segment and put the machine together. It wasn't difficult, but it was tedious. Especially, I had to spend some time getting the wiring done, but at the end, it's just working. Normally, to create my patterns, I use expanded polystyrene foam, but now I needed to buy some extruded polystyrene foam, the pink stuff. Now I'm trying to make the first cuts, and it took me some time to get all the drivers installed and have the CNC work with my MacBook. You can see these are the first attempts, but I will be already using the patterns that are being made right now. It is really magical to look how a CNC creates the pattern in just few minutes. After the patterns are ready, I'm taking them to my trusty old hot wire cutter and just bringing them to shape to cut out from the foam. Previously, I would need to create the patterns on a cardboard, stick it to the foam, trace the pattern, and get my parts. Usually my parts would have multiple components that I would need to glue them together. That is also the case now. As you can see, these little parts that I'm cutting right now, I will have to glue to the bigger component to get to my final shape. And the first big mistake. Here I'm cutting the part, but I made a mistake. I cut it in the middle. I had to turn it the other way around. That's okay. I'm gonna quickly make the part again. I'm still learning the CNC feeds and speeds, but I believe this machine that has a 500 watt spindle can do this job much quicker. This time I decided to measure the depth and set the hot wire cutter accordingly. And as you can guess it, the cut this time went okay, and I can have the part ready. Now I'm just making a few more parts that I want to have included in this pour. And right now you can see how I'm having the washer made. This part is very interesting as it has a quite thin walls, and I'm not sure if the lost form casting method is sufficient to create parts with such a thin walls. And again, the tedious part of getting the patterns cut out of the foam. It's not difficult, it's just tedious. Again, measuring the depth, setting the hot wire cutter. And my hot wire cutter is not very precise, so I usually have to do multiple passes to get to the right depth. Now the patterns are almost ready, and I just used my little X-Acto knife and a very fine file to clean them up, and using a hot glue gun, I'm assembling the tree. This part that you see on your screen right now, I'm using just a candle wax and a soldering iron to put some wax in between the seams, and that method works very well. Here I'm gluing the last part that I want to cast with this pour below the tree. Now the tree is ready, and the next step is to cover it in mud, or as professionals call it, a refractory coating. I finished the first layer, hang the patterns to dry overnight, and this is the next day. It has dried, and I'm just checking to see if there are any other places that I'd like to patch up at this time. I can see a few places that I need to just dab a bit more of that refractory coating, and the pattern will be ready to put in the sand. This part is just important for the reasons that I will have less cleanup to do after the pour. The little imperfections in the coating usually result in some bubbles, in some extra material that needs to be knocked down or grinded down, and I hang it dry. This time it is really quick. After a few hours it is ready for a casting. So let's go melt some metal. Let's see, what are we melting today? This should be enough. I have now placed the ingots in a crucible, and I'm going to turn on the machine. It is on, and now let's prepare the patterns. I just put some sand, vibrate the sand to have it settle down, put the pattern inside, and vibrate more. Vibrating the sand compacts it and helps the pattern to stay put and under pressure and ready for a pour. Vibrate just a little more, and we're ready. Now going to check if the metal has melted, see if the temperature is correct for the pour. It wasn't correct here, just a bit later it was ready, and let's pour some melted metal. Okay. There wasn't much flame, and let's shake that crucible a bit more. And now the big reveal. Let's see if this worked out or not. So far promising. So far promising. I see already an issue here. Okay. It is really satisfying to dip the hot metal into water. Okay. Oh wow, look at that. The ones that worked look just perfect. Yes. Look at this surface finish. When quenching the hot cast into the water, the refractory coating falls off, revealing the surface finish, which was really surprising. It just repeated the surface of the foam. Yep. And this part, oh yes, looks beautiful. And the washers came out very good too. And mind you, these are only a couple of millimeters. These details are quite small. Okay, now the failed part. Or may I say partially failed. So okay, only the tip has failed. Unfortunately, it wasn't only the tip. That's because of the length of the main sprue. I don't think there was enough pressure, but this looks very good. So as you can see, the lines here are actually from the CNC tool puffs. Well, this looks very promising, but I will have to cast this again. I will probably do that separately. Oh yes. To quickly show the results of today's casting, look at this. Look at the quality. Look at the surface. And this is just right out of the, right after the pour. I haven't done anything to this. So I want to show you something interesting. Here you can see the lines of the CNC tool path on the foam. Even those lines came out, and the surface is exactly like the surface of the foam when I cast it. And then these parts, the washers, look at them. It's just perfect, exactly as they were machined. There is this weird thing. This part failed in 2 places, and there is an important learning here. I used the 2 sprues, but the converging flows were too cold to fuse together, and I got that middle part which wasn't connected at all, and the part fell off after I cut the sprues. Well, that's all for me today. If you have been, thanks for watching.